I wanted to talk you through another way to think about the firm's profit maximizing problem. And this is the way a lot of texts do this, and at higher levels of economics, I'm going to ask my students to do this. So I hope you're going to take some more economics, and if you take it from me, the chances are you're going to see this framework. Anyway, here goes. Let's take Tesla Motor Corp for example, and let's suppose Tesla has a market demand and quantity sold as cars per month. Pardon my messy handwriting. Price is dollars per car. And of course, Tesla produces a lot of models. We'll call this the Tesla Model 3, and we'll just assume there's one type of Model 3. Of course, there's many varieties based on the options that you choose, that a buyer would choose. Anyway, in this analysis, we start with the demand curve, same as we did in the usual exposition. But instead of thinking about the demand curve as the feasible set, the way we're generally going to do it in this course, there's another way to think this through. We can think of the firm's marginal cost function, which is, as we talked about in class, probably at some point an upward sloping function. The difference in this way of looking at things comes about when we think about what is the benefit side of producing one more car. So we know the cost side of producing one more car. That cost side is the marginal cost. That's the cost of producing one more car. Well, if we could think of a way to say, well, what would be the benefit of producing one more car? We could think about the firm's problem in an equivalent manner. And you've already seen this on the readiness assurance process quiz, but let me just walk you through it. It turns out if the firm sold one car, it would get the price that the first buyer was willing to pay for it. So that would be the benefit of the first car. But for every car thereafter, there's this benefit of making one more sale, but since we're charging the same price to all buyers of Teslas by assumption, the marginal revenue is that new revenue from the new sale less the discount effect. And for technical reasons that you don't have to understand at this level, when we look at the marginal revenue function, if the demand curve is a straight line demand curve, as we have assumed just to keep it simple, the marginal revenue curve is a line with the same y-intercept, but that's twice as steep. So the benefit side of producing one more car can be captured by the marginal revenue function. Well, then it's the logic of economics. I will do one more thing if the benefits of doing that thing are greater than the costs of doing that thing. Well, here the thing is produce one more car. If I'm going to get $20,000 for producing one more car and it costs me $5,000, well, I'm going to do that. If I'm going to get $10,000 for one new car and it costs me $8,000 to produce, I'm going to do that. If I'm going to get $9,000 per car in my marginal revenue, and it costs me $8,500, well, I'm going to do that. When would I stop? I'd only stop where marginal revenue and marginal cost are just equal, and that's going to be my profit maximizing level of output. And what would be the associated price with that level of output? Pardon again my messy handwriting. The price that would be associated with that level of output would be the price. And that's just another way of thinking through what we have already thought through. Just for a bonus, if let's suppose Teslas are profitable at this point, average costs, this would be the ISO profit equals zero line, average total cost function, ISO profit equals zero line. Turns out that we can get a visual representation of profits too here. Remember that profits were defined as the price minus average total cost, that's average profit per vehicle, times how many vehicles we produce. Well, notice that there's a graphical analog to that. Average total costs at Q naught are given by ATC naught. So the vertical distance of this rectangle I just have drawn, that's average profits. The quantity that we produce is the horizontal dimension of this rectangle. It turns out profits can be represented by this rectangle. And so that analysis is perfectly equivalent to what we've been doing. A lot of future economics courses will use this analysis instead of the demand curve as the straight, as a constraint, the feasible set, and the isoprofit lines as the objective function. So this is something you should be familiar with. Here it is. Now you are.